Here in 13.5 through 13.6, we're going to work and start working with non-right triangles. And how does trigonometry still work within those non-right triangles? And so we're going to talk about three different laws and rules that allow us to solve some interesting information about these very real, very common triangles that just don't fit our normal description of a right triangle that trigonometry makes so easy to work with. So we're looking for shortcuts and workarounds to being able to figure out, hey, how long should AB be if I want an 84 and a 39 here and I want this to be 12? If these are things that I want in my design of a home or a bridge or other structure, how is this really going to work out? How do I figure out these distances from here to there across a lake or things like that without physically taking those measurements? Is there a way to make a calculation? And this is essentially how we can map out the stars and where things are in the universe. How fast is the Earth really moving and things along those lines. We really rely heavily on trigonometry and also not traditional right triangle trigonometry. So this is really, really fundamental. Look at some information that we're going to have. First thing we have to understand is we're not dealing with a right triangle, and we're going to give it some labeling here. That's a pretty big deal. All right, so we're going to just call angles A, B, and C today. But the other piece that we really want to do is acknowledge what the little letters represent. So a lowercase c is the side opposite of uppercase C. Little a will be the side directly across or opposite from big A, and B will be opposite of B. And in today's assignment, the first 12 problems, your job is to find all three sides and all three angles. And so the first thing we need to understand is when we go to actually coming up with the labels, if you have big A and little a, or big B and little b, or big C and little c, you can use what's called the law of signs. Now, the law of signs, I'm going to put this up here. I'm going to try to explain it, and you can pause it if you need to write it all down. But this is the law of signs. And no, you're not required to memorize this for the test. This will be given to you on the test, but it is something you want to have in front of you and want to understand the basic structure of it. The law of signs says that if you take the sine of an angle divided by the opposite side of any triangle, this will be true for that given triangle with every single side and angle comparison. So the sine of capital A over little a will be equal to the sine of capital B over little b. Or I can say it's equal to the sine of capital C over little c. The key is that I only really need two of these. So maybe I do A and C, or A and B, or B and C. I'm only going to take two of these fractions at a time. I'm not going to take the whole thing. And just like you'd expect, 1/4 is the same as 2 over 8. If we flip those to 4 over 1 is the same as 8 over 2, we still have equality. Okay. So when it comes to using these two different versions of the formula, my recommendation is to always start with your unknown on top. That's not a requirement. You can solve this without rewriting the formula, but if you're looking for little b, use this version of the equation. Don't use the top version. The algebra is a lot easier to solve if we put our variable that we're looking for on top of the equation. Let's take a look at an example problem and see if I can avoid screwing this up too bad. Let's say that the angle A is 60 degrees. Okay. Angle B is say 40 degrees. Okay. And let's give little a, a 13. Okay, that should work fine for us. So our goal is of course to say big A, big B, big C. A, and I could go to one decimal place this problem. First off, I know capital A is 80 degrees. I know capital B is 40 degrees. And just by using the rule of 180 to my degrees, but subtract 80 from 180 to 100, subtract 40 from 60 degrees. So even though I didn't know capital C to begin with, I do know what it is now. Click off my list. And the other thing that I know is that little a, directly across from big A, is 13. So now I can use the law of sine. So the question is, what am I looking for? Eventually, I need to find B, and I need to find C. These are the lowercase letters. So when it comes to using these formulas, I'm going to go ahead and choose the bottom version because it has B and C on top. That's important. We're only going to solve for one thing at a time. So let's say that we're looking for little b. That would be the sine of big B. And that can equal. Now, if I write C over sine of C, I don't know little c, which means I can't actually solve. I want to use one fraction that I know everything about. And since I know both a's, I'll put little a over the sine big A. That's why we need to know a complete set. Both a's or both b's or both c's. A lot of times won't work if I don't. So b, I'm not sure, but over the sine of 40 equals little a is 13 over the sine of c. Now, 13 over sine of 8, this is all a calculator problem. I actually like to come over here and say, how do you get b to not be divided by the sine of 40? Well, the reason I would like to put that on top, unknown on top, is that this process is pretty similar. I'm going to times both sides of the equation by the denominator, sine of 40. Now notice, the only thing left over here is b. So b will equal this to the calculator. Let's grab our calculator and see how that goes. I'm going to open up another page here because I don't want to show anybody their grades. All right, this will work for me. Come on. Here we go. All right, so we're going to come over here, go to Desmos. Of course, we still need to change things into degrees. So first thing we're going to do is flip to degrees. And we're just going to type in what we had, which was 13 divided by, and I'll grab my trig function, sine of 80, that was A. And I'm going to come out here and go times the sine, oops, I'll just use the function key here. I can't remember, if you type sine, it might take it. You can check on your own. But I end up with 8.5 as my final answer. So we're going to come back to here. So here I can put my 8.5. I need to do the exact same thing in order to find C. You cannot use Pythagorean's theorem unless you have a 90-degree angle. So I would just plan on not using it. Instead, I'm going to just do the same thing. Sine, or C over the sine of big C, which is 60, equals, and I'm going to stay with the 13 over sine of 8. Here, instead of timesing by the sine of 40, I'll times by the sine of 60. And that, again, goes into the calculator. Now what's nice about this is I can actually just come right back in here into Desmos and go with a 60. And I get 11.4. So I think that's what we'll go with as our answer here. We'll see 11.4. Just real quickly, your biggest angle should be across from your biggest side, and your smallest angle should be across from your smallest side. Now this one was nice because we had two angles, so finding the third angle was a piece of cake. We do need to talk about how do we find when we don't have enough angles to find the third angle that way. Maybe we only have one angle. Let's look at one more case for these first 6 problems. And let's see, we've got ourselves a triangle, we'll call this A, B, C. Let's say that I tell you angle A is 50 degrees. Okay? And let's see, side A over here is going to be 15, and B is going to be, angle C is going to be 13. There we go. Capital A is 50 degrees. Capital B is unknown. Capital C is unknown. Little a is 15. Little b is unknown, and little c is 13. So I do have a complete set in A right here. So I can use the law of sines. I only know stuff about C though, so B is useless to me right now. I'm not going to be able to do anything with it for a while. When I look at my law of sines stuff, when we look at our law of sine stuff, because we're looking for capital C, which is a big letter, we want to use this top version. And so we'll use the A information, and since we do know little c, we'll use the C information, which tells me that the sine of my capital A 50 over my little a 15 would equal the sine of my capital C, which I don't know, divided by my little c, which is 13. Now this is where it's slightly different. We're going to start with the same idea of timesing by what's in the denominator underneath my unknown. That's going to stay the same. And I'm going to still go ahead and put this into the calculator. But now over here on the right, I have to remember, it's not C that I have. I have the sine of C. Okay, so I haven't actually finished solving this. Go back to our calculator and let's evaluate the sine. Let's try it. SIN of 50. Yeah, it looks like it might be working. Divided by 15 times 13 gives me 0.664. Come back here. 0.664. Now what we have to realize is that to get C alone, now we've done this before, but to get C alone, we have to remove the sine function. To do that, we need the sine inverse. But to put the sine inverse on the right, I have to put the sine inverse on the left. So in order to find my capital angle, my capital letter angles, I always have to take the sine inverse of that decimal. So we go to our calculator, and we are going to take this one. I'm just going to sine inverse of 0.66391. Quite a few decimal places. This is 41.6 degrees. And so I can say that C is 41.6 degrees. So now that I know that C is 41.6 degrees, I can subtract from 180, and 180 minus 50 is 130. 130 minus 41.6, we'll just be lazy and grab our calculator. 180 minus 50 minus 41.6 gives us 88.4. So even though this wasn't a right triangle, it's pretty close. 88.4 degrees. And now that we know everything but little b, we can actually go back to what we were doing on the last set. I'm going to slide this up and say that little b over the sine of my 88.4 equals little a 15 over the sine of 50. If we times by the sine of 88.4, we get that little b equals, come in here, go 15 divided by the sine of 50 over times the sine of 88.4, and we get 19.6. Okay, so if we come here to 19.6, put that right here, 19.6, biggest side across from biggest angle, smallest side smallest angle. That's all you're going to be doing. I mean, I'm asking you to solve these triangles. Give me everything. This is exactly what one of the test questions is going to look like, and it's critical that you understand the law of sines in order to make the law of cosines, the next problem set, a little bit easier to work with. Good luck, and ask me your questions in online time.